Hello everyone. So we start with the first problem. Here first problem is we have to find the domain of this function which is given as fx equal to 1 over x plus 3. Note that function is not defined when its denominator becomes 0 because 1 over 0 we don't define. So since x plus 3 equals 0 at x equal to minus 3, the domain of the function is the whole real line except the value at minus 3. Okay, therefore the domain of the function is r minus, you have to subtract the set containing the singleton value minus 3. So that's the domain of the function. Okay, the function can we can uh, we can put any value in the function other than minus 3. Okay, now in the second problem we have to find the distance between these 2 points 1 comma 2 and 3 comma 2. Okay, now since the distance between any 2 points in R2 where the 2 points are given as x comma y and w comma z, distance between these 2 points is given as the square root of z minus x whole square plus w minus y whole square. Okay, so by applying this formula to these 2 points 1 comma 2 and 3 comma 2, you can see that the distance between 1 comma 2 and 3 comma 2 turns out to be 2. Okay, now in the third problem we have to find the polar coordinates of Cartesian coordinate 0 comma 3. Okay, now again so what are polar coordinates? So if you have given some point in R2 whose Cartesian coordinates are x comma y, then the distance of the point from the origin we denoted by r, and the positive angle it makes, the line joining the point and origin, that line, if that makes angle theta with the x-axis in the positive direction, then that r comma theta, we say that is a polar coordinate of point x comma y. Okay, now you can see that this triangle, because this is right angle triangle with these two sides x and y, hypotenuse can be calculated using the Pythagoras theorem. Therefore r is equal to x square plus y square under root. Okay, and similarly you can see that again y is r sine theta and x is r cos theta. Now from these things theta will turn out to be tan inverse of y over x. Now if you just put these values of 0 comma 3 in place of x comma y in this equation, it turns out that the r is 3 and theta is pi over 2. Therefore the polar coordinates of 0 comma 3 are 3 comma pi by 2. Okay, so now we start with the fourth problem. In the fourth problem you have to find the least value of n such that the n minus 1 derivative of function f becomes 0, where fx is x to the power 4 minus 5 times x cube plus 11 times x square minus 7. Okay, now to find the derivative of f we use these two facts. So what are these? First one is the derivative of x to the power n is equal to n times x to the power n minus 1, and the second thing is the derivative of sum of two functions is same as the sum of the derivatives of individual function, where we have assumed that both f and g are differentiable. Okay, now using these things we just successively calculate the first derivative, second derivative, third derivative, and so on, and we'll see that at which point it will become 0. Okay, now the first derivative is 4 times x cube minus 15x square plus 22x. Again, second derivative of f is 12 times x square minus 30 times x plus 22. Third derivative of f is 24x times 24 times x minus 30. And fourth derivative of f is 24. Now you can see that because this fourth derivative function is constant function, the fifth derivative of f turns out to be 0. Therefore, the minimum value of n which you are looking at, which the n minus 1 derivative becomes 0, is 6. Okay, since n minus 1 has to be 5, and then n has to be 6. Okay. In this fifth problem, we have to find roots of a quadratic polynomial. The polynomial is given as 12 times t square plus t minus 1. Okay, so for finding these roots of this polynomial, we will first we will divide the whole polynomial by 12. So it will give you t square plus 1 by 12 t minus 1 by 12. Now again, notice that 1 by 12 can be written in two ways. In one way, we'll write 1 by 12 as sum of two fractions. In another way, we'll write 1 by 12 as product of two fractions. Okay, so 1 by 12 is same as 1 minus 3 minus 1 by 4. And again, minus 1 over 12 is same as minus 1 by 3 times 1 by 4. Okay, from this expression, you can see that it can be written as t plus 1 by 3 times t minus 1 by 4. Okay, now to find the roots, since we know that 12, at the values at which 12 times t square plus t minus 1 becomes 0, if and only t plus 1 by 3 times t minus 1 by 4 becomes 0. That will give you either t plus 1 by 3 is 0 or t minus 1 by 4 is 0. That is same as either t is 1 minus 1 by 3 or t is 1 by 4. Hence, roots of this polynomial f are minus 1 by 3 and 1 by 4. Okay, so here we conclude this week's assignment.